Hey, good afternoon and welcome back. People online, are you able to hear me?
Yes, sir.
Yes, sir.
Thank you for the confirmation. So, what do you think we are going to do this session? I'm listening. Shashi, you will have to sit with somebody, you cannot sit by yourself. Might become okay. So, hey, I'm seeking input. What do you think we are going to do today? I'm asking a question, now I want an answer. Okay, let's all take a nap. If you don't want to do anything, come on, don't be
Data utilization.
data utilization. Okay, I had given you a hint yesterday that I'm going to continue what we did yesterday afternoon in the tutorial. We will work with the same data set. You were not here yesterday afternoon, right, for the tutorial? No. Do you have access to the data? Yes or no? Ritesh, did you not send it to all the participants? All right. So, what we are going to do is work with the Microsoft Excel file called 1.2 Nevada crash data. Yesterday, I spent some amount of time describing to you the contents of 3 worksheets there, 3 tabs, and you worked on one tab which was the statewide crash data, which had 300 crash records. But I told you not to work with the other 2, the person table or the vehicle table. So, what I want you to do today for the, I believe the tutorial goes on till 4 o'clock, right? Does anybody have to leave before 4 o'clock here? Anybody online, do you need to leave before 4 o'clock? Okay.
No, sir.
All
No,
right. If you have to leave, you need to speak up, otherwise,
sir.
yeah. So, I will be try to wrap up exactly at 4 o'clock. So, we are going to do the following. I will give you the overview and then we will take it one step at a time. The first step is for you to work with the vehicle table and the statewide crash data table. So, 2 tables, you will refer to 2 tables, the vehicle table, statewide crash data table. See how you can use data from these 2 tables to answer questions. So, first step is ask a question or 2 or 3 questions that you would like to answer based on the data that we discussed are available in these 2 sheets. So, the first question is formulate your question. The second task is what specific data elements do you need from these 2 files to answer the question that you asked. And third is do the analysis, fourth is summary. So, today I will tell you how much time, 20 minutes is what you have to do the analysis. Then we will go into 2 minutes per team, summary like yesterday, but I will give you the opportunity if you want to share your screen. You should be able to, right Ritesh, everybody has the ability to share their screen, right? If they log in, no? Okay, you can bring your computer here, and if you have an HDMI, is there anybody who does not have an HDMI port? Okay, otherwise I will ask the technical staff. So, you can bring your computer here and use that to share. Questions? The second, after you make your presentations, 5 teams here, 5 teams there, 10. So, we will need 20 minutes for that. So, 20 minutes for the exercise, 20 minutes for your presentations. So, let us start now. If any of you online has a question, please speak up. I will try to address your question. Otherwise, I am going to walk around the room here too. And temporarily, I am going to disconnect my computer to allow others to.
Also, they can join the team meeting and they can share information.
Okay, that is fine. That's what I asked. Do people in the room have the ability? Need to discuss with your teammates what you want to answer. अपना अपना नहीं, ये टीम का है. आप लोग कल नहीं थे, इसीलिए I'm trying to drive home the point that it's a teamwork. He knows, and you need to drive home the point with him. तो बीच में बैठना. It's okay.
Hello, sir.
Yes.
We have to start working on this person table.
You have to use vehicle table and statewide crash data table too. You have to tie together data from both the vehicle table and the statewide, not the person table. Do not touch data from the person table.
Okay, sir. Oh, okay, sir. Thank you. Thank you, sir.
You're welcome. आपने ये ऐसे ही कॉपी करके उसमें नहीं so that will not work क्योंकि देख लेना ये all right everybody, that's 20 minutes is up. So like we did yesterday, I'm going to have each of you provide a 2-minute summary of what your team did. So let me start with, we have 5 teams here, 5 teams online. So I will alternate between a team here and a team in online. That's okay. Be ready to share your screen. Are you logged into the session? If you don't want to share your screen, that is okay. You can make an oral report. Acha, let's start. You're ready. Online, how many people need more time? Okay, everybody. All right. Any online teams ready to make a presentation? Team 1, are you ready? WhatsApp group 1. Are you able to hear me online?
Yes, we can hear you, sir.
Okay, so team WhatsApp group 1, are you ready? Now if nobody is ready, then I don't want to waste time. I will give you all another 10 minutes because I see several teams here are also struggling. Okay, so let's go with Ashagre's team. Please introduce yourselves and you have 2 minutes. Let me start my timer. You're on.
Okay, we try to basically
introduce your team.
Yeah, our team is Crash Dummies. Okay, so we are using this data to use this crash data is the common denominator between these state-wise data and vehicle table. And our objective first was to ask the question, what was the influence of weather? Okay, so we created a pivot table. It's simple between yeah, pivot table between the fields that you see over here. Simple fields, crash number, crash date. We also use the crash time, but this was not of significance. What was significance of us was the fatalities. Was there any fatality, and was it because of the weather? So The weather conditions were one of them. And we found a clear pattern that of all the distribution of all the crashes, that is 37, the cloudy weather was the most contributing factor, dominant, most dominant. Rainy was also there. So this lead to 33, almost 90% of the fatalities. So that is what we are concluded over here using the weather as the pattern, okay. So next what we did was like, we tried to figure out whether this was really influencing by a type of a vehicle or not. So we again use this data to filter out where we could see this kind of stuff, okay. For example, 2 units crashed, okay. And interesting, if you see, this was our thinking that this is Christmas Day, okay, before and after Christmas Day, or just before Christmas Day, yeah. So something if has happened over here, it has happened on this one. So this is a very clear indicator that this van really went out of, we used that filter itself, okay. We really ran out of while negotiating a curve. So makes sense. To some extent it makes a sense.
Okay, that was your
Yeah.
2 minutes. How did you combine the two tables? I know you said you used that field, but physically what tool did you use in Excel, or did you do brute force?
No, it was not. It was a clear. Use of the pivot table. It's a very
Pivot table?
pivot table is very. So this is how I correlated rows and columns.
Okay, so how did you combine data from 2 different sheets in a pivot table?
No, we didn't. We used this as our interpreter,
Okay.
and that was as a data miner.
Okay,
So we use
good,
a
thank
filter.
you, because there are some participants who are new to this process. That's why I wanted you to explain. I am somewhat familiar, but when you say that, I want the other participants to benefit from the techniques that you're using.
Yeah. Wheel-
Thank you.
Yeah. Thank you.
So that's it for crash dummies. All right, team number 1, WhatsApp group 1 online. WhatsApp group. Tazim, are you not WhatsApp group 1? Okay, WhatsApp group 2 online. Anybody from WhatsApp group 2? Oh, come on. WhatsApp group 3. This is going to be a very short session then, if none of you are ready. Are you able to hear me online? Could somebody please speak up online?
Yes, sir.
Okay.
Yes, sir. Yes, sir. We can hear.
Okay, so now WhatsApp group 3, anybody ready to present? No. WhatsApp group 4. Ready?
Yes, sir.
Okay, are you able to share your screen? Do you want to share your screen?
No, I'm okay like this.
Okay, so let's start. Are you ready? I'll start the timer.
Yes, sir.
Okay. Thank you, Pratyush.
Just-
Introduce your team.
Yeah, my name is Pratyush and I have Shruti along with me. So we did some basic analysis and combined those using crash num, the 2 sheets. We combined using the crash num and some what results we got are I will list out few results. High crash areas are concentrated in urban regions, and rural areas experiences fewer crashes, but they are more severe and have a high fatality rate. And then we will talk about vehicle involvement in crashes. Passengers cars amount for the highest number of crashes, then SUV, and then trucks. Trucks and commercial vehicles, they contribute to higher severe crashes. And motorcycle and bicycles are involved in fewer crashes, but have like a higher fatality rates. And like if we did by month analysis also, we found that January, February, and December had the highest crashes, with January with the highest number of crash. The reason may be due to the adverse weather conditions. And Then we found out the peak crash hour, like we discussed last evening. It was 6 p.m. to 9 p.m., particularly to 6 to 7. And most crashes occurs on Fridays and Saturdays due to the increased like weekend traffic. And one thing we found out was alcohol-related crashes, which was most alcohol-related crashes occur at night between 9 p.m. to 3 a.m. And the alcohol involvement increased on weekends. Due to the alcohol, the fatal crashes also increased, and head-on collisions were the deadliest and were on the highways, and rear-end crashes were most common, but less severe.
Okay, thank you. So, some of what you did, you combined. The first part of the analysis you summarized, it was clear to me that you combined data from the two sheets, but the later part of the
Yes, sir.
analysis you did could have been done with just either one of the two. So, my
Yeah.
target was for you to be able to work with data from both, and what you said, what you reported now is very much in sync with what I showed you on several of my slides yesterday. The case study that I did, I summarized nighttime, weekends, alcohol, so on and so forth. So, I am glad that this mini data set mirrors what we saw yesterday from the case study.
Yeah.
What specific technique did you use to combine the data from the two sheets?
So
I know-
I coded. I did some coding with crash num.
Yeah,
I using Python and all,
okay.
and then I like segregated both the sheets, and then we found out.
Yeah,
And
so
Shruti
you
helped
did
me in,
a,
like finding all the numbers.
you used an external application to be able to sync the two. Once again, the purpose
Yeah,
of
I
this,
don't have idea about pivot table.
yeah, the purpose of this,
I'm lacking hypercontrol. Yeah.
yeah, the purpose of this tutorial is to build on what we saw were independent data sets and how to link data sets. So, I am glad you used a tool outside of Excel. The previous team used tools available within Excel. All right. So, which team? You folks wanted just 1 minute. Are you ready to present?
Yes.
Are you able to share? Do you want to share?
No.
Okay. So, please introduce your team and let's go. Start.
In my team, my name is Satyam, and I'm with my partner Sashi. So yesterday we did crash severity, in which we found that K was 43.6% of total and A was 56.3. So now we are going to do how many units were involved. So when we saw, first I'll talk about only of A. 1 unit was 109, 2 was 49, 3 was 9. 4 units were 1, 5 units were 1, and like the range was from 1 to 6. Similarly, I did for A and K, and then I found out what percentage was there. There were many blank values also when we combined from both the first sheet and the second one. So when we found out that in A the percentage was 21.89, 9.84, 1.81, 0.2, 0.20.
That's the number of vehicles involved in the
Yes.
crash. Okay.
Similarly for K, it was 15, 8, 2.2, 0.6, 0, 0.2. So we can say that as more number of vehicles are there, percentage decreases. And there were many blank values also. So they differed from 23, 11, 3, 1, 0.4, 0.2. So this is what we found out when we combine crash severity with unit numbers involved.
Okay. Did you do any other analysis? No, that is okay. If you didn't do,
Yes.
I'm not.
No.
So, what technique did you use to link the two data sets?
Simply, we combined crash severity and unit numbers involved. I already had the pre-existing crash number, so
Yeah.
with that, I found out.
But today you did not merge the two data sets. You took the results from yesterday and then you did the analysis separately today.
Yes.
Yeah, but my challenge to you was to try to merge the two.
Yes.
Okay, good job. Online, team number 5, are you ready? Any other team online who is ready to present?
Hello, sir.
Yes?
Sir, I'm Aishwarya from team number 5.
Okay, all right. Are you ready? Do you want to share your screen? There's no requirement.
Just a graph I have to show.
Yeah, if you want to share your screen, you can do that using the share your screen. Otherwise, you can just speak to your.
So I'm unable to share. I don't.
Okay. Just,
So my group we have Mr. Abbas and Mr. Verma, and we try to identify like based on this. We first classified the area into 4 zones: north, south, east, and west, and we try to identify the percentage speeding in each zone, and to link both the Excel sheet file. We tried to know whether the speed violation was under the influence of alcohol or not. That was what we were trying to do, but we were not able to merge the two sheet or combine it. And we have done for speed violation, and it was identified that
yes, Aishwarya, you're gone silent. What did you find for speed violation?
so is my screen visible? Like I don't.
Yes. Excellent.
Okay, it was seen that in West there was speed violation. The total accidents were percentage of speed violation were less, but the total accidents were less, but most of it was covered with the speed violation. And we have observed a relatively similar pattern for North, East, and South. And like all the expansion were near to 20 to 30%. The speed violations were in the range of 20 to 30%. That's all we were about to find.
Okay,
Thank you.
excellent. So one thing, when you say north, east, west, south, is that the direction of travel?
Sets the direction of travel, and based on the direction of travel, we assume that kept it in one zone.
Okay, so each direction of travel is, you're calling it zone. Is that correct?
Yes, sir.
And so I'm trying to understand your graphic. What the blue is percent in zone means percent within the posted speed limit. Is that correct?
Actually, the percentage of crashes in that zone.
Okay, blue is the percentage of crashes and orange is the percentage that exceeded the posted speed limit. Is that what you're saying, or is it that's the speed?
Mm-hmm.
Oh, they were cited for a speed violation. Now I understand. Can you move the chart just a little? I see the table and I'm intrigued by the table in columns J, K, L, rows 3, 4, 5. Either minimize the or reduce the size of the chart, just the figure.
So I have moved it. I don't know whether you are able.
No, that is okay. But if I
So I
understand,
am moving it. It's not on over the. It's not overlaying now. Can you?
not quite. For us, we still see it. That is all right. Thank you. But one thing you mentioned is you were not able to link the two tables. You just did it independent.
Yes, sir.
Okay, so once again, what I'd like you all to look at are, there are very simple tools within programs such as Microsoft Excel that you can use to tie together records that have one common identifier. The first team, the crash dummies, showed you one way to do that. Team number 4 that presented did some scripting outside of Excel to try to merge the thing. So that is some skill that I urge you, if you're going to be working with data, pick up those skills. You have Microsoft Word, Microsoft has lots of online free tutorials that will help you understand what you can do there, or there are many other tools. I'm not promoting Microsoft Excel. I don't have personal shares or stocks in Microsoft Excel, so don't get me wrong on that. That's a popular tool. That is freely available, accessible, so take advantage of that. All right, here which team wants to go next? I'm going to go to the team at the back, Ritesh, Abhishek, right? Akshay, yeah. Are you 2 teams or 1 team? 2 teams, oh, good. So Akshay's team, are you going to share your screen or not?
Yes, sir.
Then go ahead and quickly share your screen. Ashagri, I see 2 of you. It's okay. You can stay signed on. It's okay. I'm just pulling your leg. Is that your screen?
Yes, sir.
Okay.
Sir, let me start.
Yeah, I'm not sure why we are not seeing it on the other screens, but I will take a look there. Yes, go for it.
Good afternoon, everyone. Our team consists of Rajesh sir and myself, Akshay. So what we have done is we try to find out the critical crash IDs. So if you see this table, we have used pivot table. So we found out the crash ID, then the count of hit and run, and count of vehicle type. So out of these, we found out a graph, and we identified 2 critical crash IDs. So that is marked as red color. So 2 critical crash IDs were found, which is having hit and run of 6 cases and vehicles involved as 6. So with that crash ID, we went to the statewide crash data and found out all the other details like the crash type, location, date and time, pedestrian involved, alcohol influence. Similarly, with the vehicle table file, we found out the vehicle types involved, the make, the model, everything. So from those 2 critical IDs, we can get the other details. So that is what we have done.
Okay.
Thank you.
Good job. So it's interesting how you combine the two. You did a brute force approach. On the vehicle table, you found out what is the most prevalent or the crash that is of interest to you, identified the crash number, and then brute force, you use that crash number and went to the other file to identify characteristics of those crashes. You can do that when you're working with 200 or 300 records. But when you start working with 40,000, 400,000, 4 lakh records, that is not necessarily the most efficient or effective way. Okay. All right. So now let's go back online. Teams WhatsApp group 1. Will you stop sharing? Okay. Thank you. WhatsApp group 1. Is there anybody from WhatsApp group 1 online? Nobody present. Okay, WhatsApp group 2, anybody present? No. Potnuru Karan, I am seeing that name for the first time, and Nishad, I'm seeing the name for the first time. Would you please introduce yourselves? Are you here? Oh, okay. Thank you. All right, so I'm going to go to the room, so I will have your team make the presentation. Are you ready? I'm going to start the timer. Start.
Good afternoon, sir. So my team is Team Nishal. So firstly, we did.
Introduce yourselves.
Okay, so my name is Nishad, and he's Rohit, and she's Arshita. So like, firstly, we segregated the number of vehicles and number of crashes involved with the number of vehicles. So we got to know that more number of crashes involve less number of vehicles, and we also did this lane distribution, like in which lane which lane included the more number of vehicles. So we got to know that lane 1 included the more number of vehicles, which is 47.5%. And lane 5 included less number of vehicles, which is 0.8%. And we did this this one. We also analyzed in the form of charts also. So yeah, we did.
Okay. So which it looks like which tables did you use?
From statewide. Yeah, from both the sheets actually.
But how did you link them? It was not evident to me how you combined the two.
So we didn't link, but like we got the data from statewide crash data, like the number of crashes, which involved the number of vehicles. And from vehicle data, we got to know the lane distribution,
Yeah, but they are kind of independent.
But this much we could do.
That is okay. Once again, the same point I'm making. One part of this course is for you to understand that you may get data from different sources. You have to find ways to merge them together, and the common
Yes.
ID is the one.
Yes.
Okay, thank you.
Thank you. Thanks.
So, Ritesh, is your team ready? So, stop sharing your screen, Nishat. And I'll let Ritesh then take over. Ritesh,
इसमें कौन सा करना है स्क्रीन शेयर हो रहा है ना
is that your screen?
Yes, sir. Good afternoon, sir. I am Surya and my teammate is Ritesh. Sir, yesterday we had shown road surface type versus crash severity, whether is it injury or fatal. So you said that concrete roads are high speed, but the speed data was not available in the state-wise crash data. So we had used the VLOOKUP in Excel, and we linked with the crash number, and we checked is it really that concrete roads vehicles are traveling fast or not. So here this is the graph. So but
What is on the y-axis?
this is y-axis is number of observations. This color coding are 0 to 20 km per hour, 20 to 40 km per hour. Like
Okay.
that. So major difference is not found between the asphalt and concrete. The distribution here also 60 to 80 km per hour most of the vehicles are traveling in this range, in concrete also and in asphalt also. But yesterday we observed that more fatalities are observed in concrete.
Okay, interesting.
Even though speeds are not that high.
Okay.
And another analysis was speed versus severity.
Yes.
And here fatal injuries are very low at lower speeds, and fatalities are higher in higher speeds. As speed increases, we can see the proportion shifting towards other side.
Yeah, but on the y-axis it is a count of crashes, right? Not a percent.
No,
Yes.
count, yes.
Anything else?
No, sir, these two analyses we have done.
Okay, thank you, Surya and Ritesh. So the question here I have for you is on the concrete versus asphalt that you were showing. Because the concrete roads had, concrete surface roads had far fewer crashes, I'm not sure it is a statistically significant finding. Instead of the number of crashes, can you show me the chart again? So if you look at, you had a figure. Yes, speed. So on the y-axis you have number of crashes on that.
Yes, yes.
Why don't you make it a percentage of all crashes? Okay. Percentage, let me just use a rough example. Maybe on asphalt where you have all those big bars, the second set of asphalt, asphalt 1, add up all those crashes. If all those crashes added up to 100, what percentage of that was in each of these speeds? Same thing. So it's percent of crashes in that particular case, not percent of all crashes. Then same thing, do that for concrete, and that will give you an idea of whether or not there are apparent discrepancies. You have to do tests of statistical significance to figure out whether or not it is certainly different. But the other part here also is we only have 300 crashes, and I believe only a small part of that is on Interstate 15, which has paved concrete pavements, and maybe a little bit of Interstate 11 has concrete pavements. Most others are asphalt pavement. So the extent of travel that you see, extent of mileage or kilometerage, is much smaller on concrete. So that's why you see the counts to be smaller. All right, thank you. And I like the fact that you use VLOOKUP, but then did you copy all the 300 numbers for the crash from the crash number and use the VLOOKUP in this other?
No,
You just
Bo-
reference that
referenced
column,
with
reference
other-
that column for the VLOOKUP,
Yes.
and then use the VLOOKUP on the vehicle table.
Yes, yes.
Okay. Yeah, that's another interesting way to link the two. But the VLOOKUP worked here because you only had 300. If you had 40,000, it's much more laborious. I saw that you had pivot tables in there.
Yes.
That would have been a much more elegant way of linking it. The first team did a partial pivot table analysis.
First we applied VLOOKUP and then we applied pivot table.
Pivot table. Okay. Thank you. Anybody online, are you ready to make a presentation? If you'll stop sharing your screen. No, okay, not hearing anybody online. We have one more team here in the room. You folks are not ready. Okay.
Actually, we tried with the traditional formatting.
That's okay. That is okay. I want you to work. The big part of this is to work. So I told you I'll wrap up at 4. I know some people have other constraints at 4. So let me talk about a few observations based upon your presentations yesterday and today. I mentioned this yesterday. When you ask a question, look at what actionable thing are you addressing. Daylight versus nighttime, yes, it is good to figure out where it is happening and then tying it to whether it is rural locations or urban locations. So now if you find that the nighttime crashes are disproportionately high compared to daytime crashes, maybe lighting is better. But then is it practical to provide lighting on long stretches of rural roads versus were they at intersections? So try to go down to 1 or 2 levels of thinking as to what question you are answering. Direction of travel, I know one of the teams mentioned north, south, east, west. It is okay for a theoretical exercise perspective, but if you are looking at a particular small area where you may have issues, I can understand that. But otherwise, what actionable question are you answering by looking at the north, south, east, west? The other example that many of you used were multi-vehicles. How many vehicles, how many crashes for involving 1 vehicle, 2 vehicles, 3 vehicles, up to 6 vehicles. And as you can imagine, there are going to be far fewer crashes that have more than 2 or 3 vehicles, as was in, was it your team that did that? So what? How are you going to use that to improve safety? If the multi-vehicle crashes were occurring combine it with environmental conditions, wet, snow, fog, then you know, is there a closer correlation with multi-vehicle crashes and such environmental conditions? If so, maybe we want to post a reduced speed limit under such conditions. The other big takeaway I have for all of you is while you did the analysis and came up with numbers, absolute numbers are somewhat important in many regards when we look at is it 300 fatalities or 500 fatalities, so on. But when you are doing a comparative analysis, rural versus urban or freeway versus 2-lane road, the numbers will be very skewed because you will have much higher numbers for one condition and much lower. There it makes sense to say what percent of the crashes. You may have had 400 on the urban and 40 on the rural. If you plot it on a chart, it's going to look very unbalanced. But then look at the percent. Of the 40 crashes, I had 20% fatal, 80% non-fatal. But on the other one where I had 400 crashes, I had 60% fatal, 40% non-fatal. Now you can do the comparative analysis, and I had shown you a few charts. I will make sure that you get copies of my slides as PDF. So I showed you both the numbers as well as if I were to normalize it for 100%, how would it? Now you can track differences. Is there a disproportionate percentage, proportion of a type of crash or number of vehicles involved in certain contexts? So think about both. It's just not the absolute number, but the relative number. The relative number comes from the percentages. And when you are doing analysis tomorrow, I will introduce you to a few modeling things. We are not going to do any modeling where you can account for more than one contributing or causal factor. When you look at all of these, okay, can you come up A simple model is a linear regression. A linear regression is not necessarily appropriate here, but there are other models. I will not go into a lot of technical detail on that. If any of you are interested in that, we can have a conversation or communications outside of that, and I'm sure your faculty members here and at your respective home institutions would be interested in working with you on trying to develop modeling approaches. But in terms of your descriptive or summative statistics, you can still have 3, 4, 5 variables either in pivot charts, pivot tables, and think about having 2 axes. Excel allows you graphics, well, 1 axis on the right side, 1 axis on the left side, and you could show different things. So maybe some variables on a scale of 0 to 1000, others maybe on a scale of 0 to 20. You can have a mix of bars for one set of variables and lines for other, and even on the bars maybe 4 sets of bars. Maybe it is cars, pickup trucks, big vehicles, and freight vehicles. So 4 bars. So now on one chart you are accounting for 4 variables in bars. I wouldn't go to 10 or 12 bars for each thing, and over time maybe 4, 5 bars people can discern differences. And then on the y-axis, the second y-axis, if you have some other variable, you could have 2 or 3 or 4 lines there. So in one figure you are communicating information about 5, 6, 7 different variables. So the power of communication is very, very important. You can do all the analysis you want, but if you need 15 minutes to explain it, the district collector or the superintendent of police or DSP may not have 15 minutes. You show them a picture and say, sir, this is what it is, or madam, this is what it is. You will catch their attention in maybe 30 seconds to a minute. You don't have to go through all the details, just say here are the trends. We see more trucks involved in crashes between 9 p.m. and 6 a.m. on rural roads. Here are the data. Oh, okay, so maybe we need to have more police, or maybe we need to have more light. Or on rural roads these are happening close to intersections or junctions. Do we want to put more lighting? Do we want to put rumble strips or something in advance of the intersection? So those are actionable things that you are bringing to people's attention. So think about that. Doing analysis for the sake of analysis, learning the analytical techniques is good, but what is better is doing things that you can communicate effectively to influence a decision. Do any of you have any comments or suggestions?
Sir, actually we are not able to match the data set.
Yes.
Numbers.
Yeah, from the 2 tables. So that's what I tried to work with you for a few minutes. Please look up. Microsoft has, and these 2 teams, they did a VLOOKUP table. There are other ways to do that. VLOOKUP is more of a brute force, I would say. When you have a few numbers, that is okay. All right.
Actually, sir, we tried VLOOKUP as well, but they are just giving that 2 of those.
No, I'm going to urge you to maybe spend 30 minutes or so to fine tune your skills there, and if not in a tutorial session tomorrow, we can try to look at things. All right. Or seek help. The whole idea why I keep telling you to say your names is know the other people, and those who have done it, maybe talk to them to see if they can help you. As I told you, if somebody did it for you, you're not going to learn. Ask others how to do it and do it by yourself. Have them stand by your side. You will learn how to do it much better than if the other person said do A, B, then C, then D. You may do it now, but you may not remember it. So learning by doing is the best way to do. Hey, we are at the end of day 3 now. I have one homework for all of you. Ritesh, I think I mentioned this to you. I need help if one of you can set up an online poll. Maybe I want you to answer the following questions, including those of you who are online. There are 3 questions. You may want to write it down. The first question is relates to presentations that Dr. Bharadwaj made, Professor Maurya made, and that I made. Okay, the questions are for all of you. List 3 things. Don't talk to anybody, please. When you come up with your answers, I want your answer and only your answer without talking to anybody. List 3 things that is being done well over this workshop, this course over the last 3 days, that you would like us to do more. I will try to adapt it for the remaining 2 days. The same question changed little bit. List 3 things that we are doing that you don't particularly like or you would like us to do less of or not do. Three things that are good you want us to do more, 3 things that are not so good, not so great you want us to not do or lessen. And the third question is, what are 3 things that you recommend to us that we have not done so far that you would like us to consider doing? Things that we are not doing that you want us to consider doing. Remember, we only have 2 more days, and depending on how quickly I am able to set up this online, I will work with Dr. Bhardwaj and Ritesh. Are you able to set this up as an online quick survey?
Hello, sir.
Yes.
Sir, could you please repeat? I had lost my connection. First 2 questions which you are telling, sir.
Okay. List 3 things that we have done in this course over the last 3 days that you like or that you feel are good and we should continue doing or do more. Did you hear that?
Yes, sir. Yes, sir.
Okay. The second one is list 3 things that we are doing that you don't think is very good or very effective and you want us to do less or not do.
Okay, sir. Okay, thank you, sir.
That's
Third one is I have noted, sir. Thank you.
okay. Chandrika Prasad, right?
Yes, sir. Yes, sir.
Okay, thank you. All right, is there tea today? Yes. All right, and I think it's getting close to 4. Some people may have to drop off. In fact, it is past 4. So thank you all. Have a good evening. We'll try to set up the survey. If you are able to access it in the evening, I would appreciate you trying to respond. So I'll take a look at it overnight. To the extent I can address it for the morning session, I will, but I'll try to address it definitely for the following session. I should have done this yesterday. I'd meant to do it. And as I told you during the first session, I'm here to learn from you also. Learn on a technical basis, learn how to communicate better, learn how to interact with you all better. Because if we can interact better with each other, we will facilitate learning much better and we will have a more enjoyable experience. All right, teams, okay?
Okay, sir.
Wish you all a
Okay,
good
sir.
evening.
Okay, sir. Thank you.
Thank you.
Bye, sir.
Bye.